Okay, so homework for today was to, we already add lit expressions. We've added lit expressions. We made it work for lit expressions, but now we have a lambda that can take 0 or more parameters instead of a lambda that takes exactly 1 parameter, right? So that was the homework assignment?
No, we need to expand apply expression.
To allow for a lambda to take 0 or more parameters.
Yeah.
Yeah. Okay. So I think I gave you this on Slack, a starting point for AppExpression. I'm pretty sure I put this up on Slack, right? This constructor. So here's like an example new constructor for AppExpression. If you went with a different direction, that's fine. But effectively what we do is we have a lambda that's going to take in a lambda calculus expression. This guy is presumed to be a lambda. So it's going to be one of our lambda calculus expressions of type lambda, and then it's going to take in a list of expressions, so a list of lambda calculus expressions. And then what it's going to do is it's going to append the list version of that lambda calculus expression with our list of expressions, giving us a list that has a lambda calculus expression with all the parameters, 0 or more parameters after it, because this could be the empty list. All right, so that's what an app expression, the new constructor for an app expression, will allow us to accomplish. It'll, so what I'll do here is I'll say app expression old, and then we'll just call this guy app expression. Okay, because now we want app expressions. Did I write it here? Or did I put it in the notes? Example inputs. It's not here, so I must have put it actually on the assignment. But in any case, oh yeah, here's some examples. They are here. So here's a new test expression. So we should be able to, I now rename this guy, but we should be able to create an app expression where the first element is a lambda calculus expression. So that's a lambda. All right, so it's our, I guess, what is it now? Our third production of our lambda calculus expression. We have a lit expression, a var expression, a lambda expression, and then an app expression. So we're assuming this first guy here is of type lambda expression. And then we're giving it a list of lambda calculus expressions. And I think for this assignment, I said it only had to work for lit and var expressions. All right, so I mean, you could have done like a var expression and given it an A or something like that, but then you have to make sure you give it an environment that has that stuff in it, and we'll mess with that. But for right now, we can just have 2 lit expressions. So the idea here is that 7 would come in for the value of A, 8 would come in for the value of B, so we need to extend our environment with those guys. So our app expression now takes on a new form. All right, so if I'm here in apply expression, so here's my lit, my var, my lambda. So now here's my else, where I'm dealing with my the operator, which will be my lambda. Correct? So this guy doesn't change. I'm still going to be dealing with an operator that is going to be a lambda expression. But now, instead of just having a single resolved operand, I want to have a list of operands. All right, and how do I do that? Well, my list of operands, so I'm just going to call this guy, let's call it list LO operands. Looperands. That's fun to say. List of operands. All right, that's what this variable is going to be. This is inside of a let. Now, I want to call apply expression on the current environment on every single thing in my list of expressions, the second element of my app expression. The rest of the elements of my app expression. So if I want to come up here and do it with my constructors, I can say here's app expression. I have an app expression get operator. Now I have a get operand, but really this guy just gives me the catter. So now what I can say is I want to get the operands, the parameters that will be going into that lambda. And what is that guy going to give me? It's going to be the cdr of my app expression, the list of operands, which will come out as a list of lambda calculus expressions. That makes sense? So when I say, so basically if I have a example here, if I go and I have an app expression where the first element is lambda a b a for whatever reason. All right, so that's my first thing. And then I want to have a lit expression 7. And just to keep it simple, we'll do our lit expression 8. If this is my app expression, the cdr of that is going to be a list containing those elements. Does that make sense? So that's what that guy will be. Now, ultimately, what I want is I want to process that cdr. But I'm going to be asking my getter here, my app expression get operands, to give me the list of those operands. And then I need to process those operands one way or another. Now, you can do something pretty cool here. Let's see, what would I do? You can make a fairly scary looking map. You can map a made up lambda that calls ApplyExpression on
it doesn't quite work with map, or at least
no, it will, because map requires only one parameter. That's why you have to make a made up lambda. So here we would so here's the operands. So let's go ahead and get the list of operands here simply first. So list of operands, I need to close that let there. So this guy is going to be, what did I just call it? App expression get operands. App-exp get operands expr. Okay, so this will boil down to the list of expressions. Make sense? All right, now I might want to do something with this list. So since I want to use this a little bit later on in my let, I'm just kind of doing it in single steps. I need to actually upgrade this to a let star. A let star allows me to have other things in my let in terms of previous variables. So now I can have a third value that allows me to use this list with a let star. So I'll go ahead and give myself another, so we're going to call this guy list of resolved operands. And this guy is going to equal the result of calling map. And I need to pass map a function. So I want to map a lambda that takes in an x. This is an expression. And what it does is it calls apply, is it called ApplyExpression? ApplyExpression on x and my current environment. And I want to do that to looperands. Like that. So the function, so what map does is it applies this function to every element in this list. So this list, looperands, is a list filled up with lambda calculus expressions. What am I going to do with it? I'm going to apply this lambda that takes a single parameter. So it'll get called for each of the elements in looperands. And then what am I going to do with that parameter? I'm going to call ApplyExpression on it, passing it that parameter and the current environment. And this should then give me a list of resolved operands. That make sense? And let me show you a picture of what that will end up looking like. Because a lot of times when you do stuff like this, people freak out. So, but let me just remind you of something, because we're going to start stumbling into situations where map is pretty helpful for us to do some stuff. We could write a function that just does this and recursively calls the stuff. But let's review what map does. So map is a function that takes a lambda and a list of elements and applies that lambda to each element in the list of elements. So in our example here, I might have a list that looks like, I'm just going to use our same lit expression thing. So I have a lit exp, what did I say, 7, and a lit exp 8, something like that. So that is my current looperands, right? So this is looperands here. That's what looperands looks like in our current code. All right, and then what I'm going to say is I want to call map. Well, here, let me show you this function first. So I'm going to have a lambda that takes an x, takes one parameter. Then you could call it expression or something like that. I just didn't want to cloudy the water since we already have an expression in there. So this lambda is going to take one parameter, and what am I going to do with it? I'm going to call ApplyExpression, passing it that parameter, which will be an expression, and my current environment, which is in the scope that we currently have there. All right, so this lambda takes in exactly one parameter. Map requires that. Map requires that the lambda can only take one param. Now, that doesn't mean we can't take one param and do more than that, do more with it, which is what I'm doing here. I'm saying, hey, look, here's a lambda. I'm effectively wrapping ApplyExpression. We can't, what we might want to do is we might want to map ApplyExpression to it. But the problem is ApplyExpression takes two parameters, not one. Go ahead.
I believe that map can take more than one. It just needs to have equal sized lists for each argument.
It's possible you're right, but not that I know of.
Okay.
Yeah, my understanding is that map has a limitation. It's kind of been a known thing. The map has a limitation that it only the default version of map. It's possible they have an extended version, but I've read some stuff where people have written versions of map that do more automatically. But that map's first parameter is a lambda, and it can only take one parameter. So as far as I know, map can only apply a single parameter lambda.
And it did work. I mapped.
Okay, so you
the
did
list 1, 2, 3, or I mapped plus onto the lists 1, 2, 3, and 4, 5, 6, and I got the list 5, 7, 9.
So you did what? You said map
Plus,
the plus, which is a variable name for a lambda, onto what list?
List 1, 2, 3. And then also list 4, 5, 6.
All right, so it passed all three of these parameters into this plus thing?
Mm-hmm.
And so it gave you just two answers?
It gave me a list of 3 answers because it added 1 to 4, 2 to 5, 3 to 6.
1 to 4.
Because it was 2 lists. Not
I see. So it assumed that your parameters 2 plus was this 1 and this 4.
Right.
And then the second time was this 2 and this 5. Interesting. That doesn't necessarily help us here, though, because we would still have to generate a list that had our environment the correct number of times.
Right.
So if we have a looperands looks like this, we would have to have a corresponding list with our environment in it twice for that one. So yeah, I guess that's interesting. I didn't realize map would work like that, but I think this is still the better approach for this one. So looparans looks like this. I want to apply this lambda to each element of this list. So the first time through, this expression will come in as x. And what am I going to do? I'm going to apply expression on that expression in the current environment. Similarly, I'll do it on this one as well. Now we do have to, not for us right now because of what we're supporting, but we do need to consider a little bit moving forward what happens if the environment actually changes from one of these things to another. It would never happen in this circumstance, but this is kind of a foreshadowing thing where if we have an app expression and we're calling apply environment on the first part of it and the second part of it, let's say, the first part might change the environment, which might impact how the second part gets executed. I would have to come up, we'd have to have more stuff to work with to give you a good example of what that looks like. But you can't necessarily say, I want to execute everything sitting in front of me inside the same environment because the second guy might be reliant on the resulting environment of the first guy. Okay, that's not our problem yet. I'm just kind of saying that that is something that we will have to deal with as we get deeper into the language. That sometimes resulting environments are the environment that we, like for instance, when we implement loops, right? Each time through a loop, something can change in your environment, right? So the next time through the loop, you're executing that body, which is an expression in and of itself, in this potentially modified environment, right? Maybe I is 1 greater than it used to be, then it's 1 greater than it used to be, then it's 1 greater than it used to be, something like that. You don't want it to keep boiling down to the same I, otherwise you've written a language that has built-in infinite loops. Something along those lines. All right, so looparans looks like this. I want to take this function that will bring this guy in as an input for each x, and I'll call apply expression on that expression with that environment. And what this will ultimately do, so if I do map, here, we'll say map that dude onto looparans, and that should give me the list 7, 8, like that. Because it will apply the expression lit expression, which just boils down to a 7. It'll apply the expression lit expression 8, which just boils down to an 8. If I happen to have a variable a, it would resolve that variable a in the environment, giving me the whatever the value in the environment of a was. Yeah.
Okay, maybe again, I'm not grasping why we're doing exactly this because this seems redundant. If a lit expression is just literally a number, why are we using the constructor of lit expression to return a number when we can just put a number in its place?
For structure, and so our predicate works. You're not wrong.
Okay.
I guess I would say redundant is the wrong word. Consistency is probably the right thing.
Okay.
Lit expressions, since they're so simple, you're saying why label it?
Yes.
Which you could say fine if that could just be kind of the else. If it's just a number, just roll with it. Otherwise, we can say this is what our lit expression looks like in the constructor. And if we always use the constructor, that then gives us the flexibility later on to say maybe lit expressions mean more.
Okay.
I don't know what that might be. Maybe we increase our number, the types of literals we can support, stuff like that. But then we don't have to go back and change all the places we use lit expression. We can just fix our one constructor, and now it builds
I guess that makes sense.
correctly formed lit expressions. All right, so we're hoping that the result of this map will give me a list with my 2 values in this example. Make sense? Now, we happen to have an extend env star already that will take in a list of variables and a list of parameters and a current environment and give you an extended environment. All right, now what is this guy? This guy looks a whole lot like the parameter list for my lambdas. All right, do I have a getter for that?
Yep. Get params.
Get params, is that what I called it? Lambda get params?
Yeah.
Lambda get params, this guy right here.
Oh, yeah, that's right.
All right, so I'm going to get my resolved operands. So I'm going to map this function onto my looperands. This is going to get me that guy. And then if I want to keep going with the, we're going to call this list of param names, something like that. Yeah, we'll say list of param names. So what is that going to be? It's going to be lambda get params with our operator. That's our list of param names.
I think we have to change lambda get params up above. I think we're.
Did you break it? Did you break it?
No, we didn't update it yet to take in the list of parameters. I don't think.
Yeah, it just takes in the first thing.
Oh, it assumes a 1?
Yeah. So you just need to take out one of the A's.
Lambda get params. So our lambda looks like this right now, right?
Mm-hmm.
So this would be the car of the cooter.
Yes.
This guy right here. There. If you want to see that a little bit longer. So what were we doing? We had the CAADR in there. Oh, we were getting the single.
Yeah.
We were getting the param, which was the actual parameter name. Now I'm getting the list of params. Got it. But my naming convention is a little funky there. So get params indicates potentially more than one.
Even though there was only one before.
Now, is that considered a spelling error?
Yeah, I think
Blaine,
I caught it now.
this is like multiple classes later.
It's okay. I came around to it.
All right. So this will just extract our list of parameter list, A and B or whatever that guy looks like. All right, what am I doing? Okay, so this is going to be my list of params. Lambda get params, giving it my operator, which is my lambda expression. That'll pull that piece out. So now what am I going to do? I'm going to apply the expression. What expression am I applying? I am applying this, it's actually going to be the expression part of my operator. So I need to do my lambda get, do I have get body?
Yeah.
So that's what I'm actually executing here, right? Is the body of that lambda? Or do we actually do that on the lambda? Yeah, we do that up here. So we're fine. We could just pass our whole lambda through because when we come through to this part, we get the body of our lambda and then pass it on to the next the environment. So we apply the body, apply expression on the body of that lambda. We don't have to extract parameters out of this guy because we've already done it inside of our app expression. All right, so I technically could do that here if I wanted to, but interpreter logic would probably say, if you have a lambda expression, how do you apply it? You call apply expression on a lambda expression, passing it the environment you want it to be executed within. So we'll call apply expression. There's our lambda expression, and it's going to be executed inside of what environment? The extend env star of param names and low resolved operands. Tonight's special at the Mexican restaurant. Fajita style. Extend env star, low param names, low resolved operands, and our env. And that should be it. So now, I should be able to call apply program on my new test expression. Take the new app expression off because I renamed mine. It's no longer called new app expression. Now it's just called app expression. Passing it my lambda AB. And the body of that is just var expression B. So this is going to take in a 7 for A, an 8 for B. It's going to bind the 7 to the A. It's going to bind the 8 to the B in an extended environment. Then it's going to execute the body. It's going to be a var expression. It's going to resolve the B down to a 8. That's what this guy should do. Must be a list received as 7. What'd you do?
The example that you give, because of the comma thing, is give you a lit exp and not a 7.
Oh, I put a comma somewhere?
No, like right there.
So
Where?
line 161,
Yeah?
we have to use the list function on the lit expressions we make.
Because
at the
it's
end of
giving
it.
you like a list.
Otherwise, it has lit expressions.
I put the quote.
Yeah.
You were calling this a comma. I got you. So I want a list of these guys.
Yeah, because I did a dumb function to get it off until I know that there's a way to do it.
Yeah, this is a different issue, it seems like.
Give me a moment. Before we call this, we're just going to output our test expression and make sure this guy looks the way we think it should look.
This is good.
Okay, so that is from AppExpression. This guy is taking in, so he's taking in a lambda expression. This guy right here, that looks legit. And then he's taking in a,
Oh.
is my constructor for lit expression wrong?
Constructor on 160.
Yeah, line 160, you only have one lit expression being passed in. That's what the issue is. It's not happy with 160, right above where you were.
Yeah, it's 160 that's getting there.
Oh,
Because it's only finding a 7, not
A
a
list.
list expression.
So this be a list containing a 7.
I understand. My test that should no longer work is what's causing an error. So it's correctly no longer working. Got it. Because I have now changed my definition of those guys.
Yeah.
There's my 8. And then if I want to pass in, yeah, whatever. I think this works. So if I want to do some other things, if I want to just output, well, I can say var expression A. This will give me my 7. So on and so forth. I can have it take more parameters, and I can have this guy take in a var expression. C, like that. And when I call apply program is currently taking the empty environment. I'll pass it my test environment, where I actually have a binding for C. I'll just give it a binding for C here. So my test environment has a binding for C already. So that's the guy I'm going to be executing my program in for no good reason. Now I have a lambda that takes 3 inputs, A, B, and D. A, B, and yeah, whatever. And this guy will boil down to var expression of D. So my parameters passing in, a 7 will come in for A, an 8 will come in for B. The value of C, which is a 3, will come in for D, and then I'm going to boil down to the value of D, which should be a 3.
Possible spelling error.
Where?
Do we need to have C as a symbol?
This guy?
Yeah.
Probably, yeah. And there's my 3. All right, so that is the homework assignment. Questions about that? Go ahead.
For like the app expression, are we just assuming that the first LC expression in there is going to be a lambda?
Always. Yeah, that's at least that's what I've advertised at this point.
Okay.
Because an app expression is always applying something to the rest. And everything the only thing we know how to apply at this point is a lambda.
Okay.
Yeah. Because the rest of the stuff is your operators or I'm sorry, your operands is the everything else, your parameters that are being passed in, and the only thing that makes sense for is a lambda in our world right now. But we can get crazy and come up with other stuff in our language, and decide that app expressions could have. I mean, we can invent a new kind of expression other than a lambda that might do some funky stuff or whatever, and that would be perfectly reasonable. But for right now, it's the only thing that makes sense, so we're making an assumption. We could force it by actually making lambdas something special rather than one of the forms of a lambda calculus expression, because right now we don't test against it. So you could pass the first element of an app expression, a var expression. Nothing's keeping you from doing that except the logic will break. Because it's going to start trying to pull out variable lists from a var expression is going to not handle that well. Okay, you can't start removing body parts from something that doesn't have them. Unless you're Mr. Gonzalez. He has a very specific set of skills. Okay. The big, beautiful hands. Okay, so right now we work for lit expressions and var expressions, but it would be nice if we can execute our more things in the context of our right now. The body of my lambda, this guy right here, is either a lit or a var expression. But is there a reason why I can't have that guy be another app expression? An app expression looks like this, open close parentheses. The first element is going to be a lambda expression, right? So we'll say lambda expression. And maybe this guy takes a, for right now, we'll keep the variable names unique because we're going to have to start dealing with scope here pretty soon. But so for right now, we'll make the assumption that variable names are always unique. Otherwise, the most recent definition of a variable will be the one that you use, which technically would match up to scope. But you could run into problems when you are executing two different expressions in two separate scopes where they both have a variable with the same name. Something like that. So we'll just keep them unique for right now. That's not the thing we're looking at this moment. So the body of this lambda expression will be another lambda expression. And in fact, what we can do here is just to keep this a little cleaner, a little more readable. I'm going to say define body to be a lambda exp that takes in a x as a parameter. And what is it going to do with that x? It's going to boil down to a var exp of that x. So that's what the body is. All right. But the body is an app expression taking in that var of x and you know what? Let's make this extra interesting. We're going to say that this is var expression d. We won't even use the x, but this guy takes in a lit expression 4. All right, so the body of my lambda will be another app expression whose first element is a lambda that takes a single parameter and boils down to the resolved variable d, which does not match the parameter. So it's another variable in my list. So that's my lambda, and I'm applying that to this single input, but this is a list, right? So this has to be a list of those guys. Go ahead.
You need a quote before the D.
Oh, thank you. Blaine?
Do you need a quote? I think you need a quote before the list for lambda expression too.
Who?
161.
161?
After lambda exp, you make that a list. Just a little dash.
Oh,
outside.
okay.
Yeah.
Jack? All right. So the hardest thing is writing the test cases. You just can't spell. Okay. So the body of my lambda down here is going to be an app expression that starts with a lambda expression that takes in a single input, chooses not to use that input. Instead, it just resolves some value D. The second part of my app expression will be a list containing a single parameter being passed in, which will be a lit expression, which will resolve to a 4. So that's going to be the body, and then I'll use body in the body of my lambda expression here. Just makes it a little cleaner than having this big long wall of stuff. So my test expression will have a lambda expression which takes in 3 parameters, and then the body is going to be whatever body is the body, and we have our 7, 8, and C coming in for that, and where C is equal to 3 in my test environment. And that boils down to D, which is the var expression we should boil down to. So the body of this guy should boil down to the value of D, which is a 3. But now the body is no longer a lit expression or a var expression. It's actually an app expression, which applies another lambda to the body of it and binds a 4 to an X, which we don't use. So our output should be a 3. Works for app expressions. Didn't change a thing. Pretty good. Now, can the body be a lambda expression?
Why not?
All right, so tell me why not then. On the surface, you're right, but in reality, you're wrong. That's the worst place to be.
I mean, as is, it takes in.
Well, let me ask you a more targeted question. What does a lambda do if it's not in an app expression?
Nothing.
Yeah, it doesn't actually accomplish anything. An app expression says, apply this lambda to these inputs. If I just have a lambda sitting here, I'm not passing anything. I have nothing to apply that lambda to. It's a perfectly nice function, but nobody's called it. Okay, so structurally here, nothing keeps me from passing a lambda expression as the body. It's just not, you can't do anything with it. The lambda expression doesn't boil down to anything unless you've applied it. Now, having said that, if we come in here and look at our lambda expression, what does our lambda expression do? It gets to the body of this guy and then does execute the body in an environment. So with that in mind, let me show you this. I can have so now my body is just the lambda expression that takes in a variable x, and the body is D. Will this work? It will. Exactly why. But now you want to see it. Go ahead.
Do we need to give it X, or could it just take in no parameters?
In this case, it would make sense to take in no parameters. Yeah, because the thing is that
If we had to give it something.
yeah. So this would make sense.
Okay.
A lambda that takes no parameters and then does something. But if I want to have that taken a parameter and then I want to use X here, it's going to die. Because without an app expression, what does an app expression actually accomplish for us? When we bindings. App expressions bind inputs to parameter names. That's what it does. So by me just passing this lambda without an app expression, I never get a binding for X. So now when it goes and tries to resolve a variable for x, unless it was already in there, he's going to have trouble. Couldn't find it. Now, I can cheat. And I can throw an x into my environment here and just say it's a 2. Now it'll work. I bound it for him. Look, if you're not going to bind something to x, I'll just put it in the environment to begin with. Now you have x. That's how we sometimes want languages to work, right? You're sitting there banging on your homework for 8 hours, and I was like, why won't this work? Well, you didn't cheat. If you want that variable you never defined to be equal to something, you got to force it. Just put it in the variable environment. All right, so does that make sense? So the reality is, your homework assignment for today, even though you were targeting lit and var expressions, actually works for all the expressions. Every one of them. You don't have to do anything special. When your perception would have been those other ones were the harder ones. Right? And why is that? Because how do we execute an expression? We call apply expression. Doesn't matter how many expressions we have inside of expressions, inside of expressions, inside of expressions, apply expression knows how to execute an expression. Some of the, like the app expression creates new bindings. It extends our environment. A lambda expression, presumably, is applying a lambda to some inputs, but, as he pointed out, it would make reasonable enough sense, since we're supporting 0 or more parameters here, for us to have a lambda that takes no inputs and just does something. That can exist without an app expression. That's a little bit funky compared to how we might think about this in Java, because you could write a function. Somewhere you have to call it. In here, we're only sort of kind of calling it, I guess. I guess we're calling it. It's the body of something else. So basically, we have a special case in a situation where lambdas don't have parameters. Your special case is either you can just use it directly because it's not creating a new binding, or you're wasting your time trying to make it look like it's going to create bindings. Don't use those variables unless they are otherwise defined. Because if I said, A in here, and then I said var, well, if I say X in here, this is not going to boil down to the value of this, because I am never creating a binding for X related to this lambda. I'm getting the X that was already floating around up here. All right, so that is our whatever. So now we support functions that have 0 or more parameters instead of exactly 1 parameter. What would come next? We're language developers.
More than one environment?
Okay. So that's certainly a viable thing to do. Do we have a use for that next? A use for that yet? I guess I'm kind of thinking about if we're sitting around, we're imagining our brand new language. At this point, we've been kind of following the rules of scheme, right? Coming up with our own versions of different kinds of expressions. Go ahead.
Are loops next?
Could create loops. They could be handy. If we want to go the environment route, we can maybe make a let. We can create our own let expression.
Branching?
We can do that. Conditionals. Dealer's choice. We're the language developers. What do you want to do? Let's make those. Those are options. So we have if statements or let expressions. I don't want to do if statements. If statements are pretty easy. So let's do let expressions or a loop. Is anybody anti-loop? Okay, we're gonna do loops. Why? Because I hate recursion. Okay, any language I'm designing has loops. Okay, so we're gonna come in here And we're going to add to our, where's my lambda calculus? Here's my grammar. So we just going to, what kind of expression? Are we doing like number-y loops, like for loops?
Oh, or while loops. Okay.
Dealer's choice.
Well, a while loop encompasses a for loop, so.
Sort of. What's going to be the problem with, tell me about loops. What are the components of a loop in Java? Let's just stick with what we know. Go ahead.
Well, for like a while loop, you need a condition also, we have to write those.
Yeah, remember that whole thing of what's a Boolean expression?
Mm-hmm.
Any expression that boils down to a single value of true or false? We don't really have those at this point. Huh?
For loop.
For loops require Boolean expressions
I
too.
suppose they do.
So really we can maybe do something like a repeat. Do something some number of times,
Okay.
right? A repeat expression. Do something 10 times. There's no Boolean for that. I just do a countdown. We're fine. Everybody, life goes on.
I like that.
All right. So we'll do a repeat expression.
But then how do we know when the countdown is done?
Well, you're going to write the code underneath the hood. I mean, you'll have to show me because at this point, you guys are writing your own homework here. So we're going to add a repeat expression to our lambda calculus, lambda expression grammar. All right. And what is this guy what's this guy going to look like? He's going to
Spelling has changed again.
Is that more correct?
Yeah, that's right.
Repeat exp. Way to go there, Blaine. All right, so we have a repeat exp. And so how's this guy going to work? What's the syntax for repeat exp? Probably the word repeat.
That would be
Just kind of like lambda, right? What does repeat start with? It starts with the word repeat. All right, what are the things that a repeat's going to need to be able to do?
Taking a function.
Okay,
Yeah.
then we're gonna do something,
Mhm.
right? And we're gonna do something some number of times. Okay, so we're gonna have a repeat. Probably. We'll call this a lambda calculus expression. We can assume it's in the form of a lit or a var expression.
Okay.
Those because we need it to boil down to a number for our count. This is the number of times we're going to repeat
okay.
something. So I can give it a lit expression and say 10. Do this 10 times. Or I can give it a var expression and say a, where a is equal to 10.
Okay.
Something like that. So, but we'll generically say it's a lambda calculus expression, but we're assuming it's of the form of something that boils down to a numeric type, because this is my number of things we're going to do. And then we're going to have a lambda calculus expression that is the body that we will repeat this number of times. So I'll give you an example here. So we'll say repeat lit expression 7. And then maybe we do a var exp, just to keep it simple here, b.
Don't we need to make a symbol for repeating?
This is the body. Yeah, this is what we're going to repeat 7 times here. So in this simple example here, this is going to resolve the variable b 7 times. Doesn't seem all that useful yet, but doing something multiple times seems useful. Now, once we can start having this guy do some stuff in here where maybe the value of b changes, that's going to be handy, right? We really can't do that quite yet. So we're going to probably have to have some something that's going to allow us to change values later on. But for right now, to repeat this expression this many times seems reasonable enough. So for Monday, add repeat expression to your language. Should have a constructor for it, and you should add it to apply expression.
And then
The example of this guy would boil here. Let me just make this a lit expression, just so I can give you. So let's just say that's 5. This would boil down to 5, 2, 3, 4, 5, 6, 7. Something like that. Now, you might decide that what you actually want to do is maybe have your output like in a list. So you might say it's reasonable to boil down to a list with your results in it. You might say that's a friendlier output in a functional language, but choose your poison. Whatever way you want to go with your language is fine. But make it so you can repeat in a lambda calculus expression a number of times, where the number is represented in a lit or a var expression. Questions, comments, concerns, bribes? I will see everybody on Monday, and I'll put the homework. Well, I'll put the homework up on the Blackboard, but I'll put the solution that we came up with today on Slack.
Before you
There's
start
a
on
challenge with the repeat, but at the same time, it's like, why is so
Yeah, repeat's gonna be easy.
Yeah, start in 3
Okay,
frames.
I wasn't sure.
Because I feel like if you're doing something like that, why don't you just do it in recursion and make n minus 1?
Because I am a
Isn't
computer.
that how you repeat?
Could work.
Maybe.
No, based on whatever you just output out, that's
What did you
basically
end up
what I
doing
come
in the
up with,
case
like
in
right away. Like
7.3.4?
if you just
I
cut the n
wrote
minus
the
1, they
point
keep going like that.
Alright.
That's literally creating that.
I just took the expression.
How did you do that?
Wrote it out. I don't know. And then.
Oh.
Sort of case.
What?